Hi, everybody. How's it going? Good, good. Hi. Thanks for joining us today. Really excited to have you all in here. We have a lot of some of my cronies in here in addition to Chris. We've got a big support system, so we appreciate you joining us today. So I am Julie Morlan. I lead product and design for Jack Henry for our digital products and our new Jack Henry platform. So we're going to talk to you today a little bit about that, not the product specifically, but how we got there. I've been with Jack Henry, it'll be 26 years in October. So I've been a part of banking for a long time. Prior to that, I actually worked at a bank in a back room and did about every job there is to do at a bank. So I am not your technical person here. I am your analyst banker person. Chris and I are a very unlikely duo because Chris is our genius architect behind our new platform. So as he walks through how we have thought about things as we move forward, what I want to try to do is frame it for you in a real life banking context, because bankers aren't like all of you, and I mean that in a very big compliment to all of you, okay? So they think about things very differently, and we're going to talk about that and what that means today, and then how we bring them into the modern era of how we want them to work going forward. So, Chris, this is the title of our session, and we had a lot of fun making up this title because this is how we want to think about it. Ledgers made of lightning. We want things to go faster, and we think banks want things to go faster. They just don't know it yet. They are constrained today by time, and time is not their friend. It is not our friend. So everything that we're going to talk to you about today is in the theme of how we make things go faster and then drag our clients along with them.
So I'm Chris. I'm a principal engineer here at Jack Henry, and I work on the platform, which is what we're going to be talking about today. So hopefully we can help shine a light on the weirdness of technology and how it intersects with this space.
And he said, here at Jack Henry, this isn't here. This isn't Jack Henry. So we have to adjust our minds to that a little bit. So that's Chris. That's me. I've already told you a little bit about myself, so we're just going to go ahead and jump in. So what we're going to go through today is the platform. Chris is going to talk through CAP theorem, and then we're going to talk through journals and ledgers, and then end of day, my favorite part of the topic, which is what brings us down in a lot of spaces. This is the mission statement that I think Chris came up with. What are we doing with the platform? This is just so you all can understand what we're building and why we're building it. A unified, cloud-native, API-driven ecosystem that connects products and empowers financial institutions to deliver modern, innovative strategies. That's a lot of words, huh? But that's really what we want to try to do for all of our banks and credit unions. And also, just in case you don't know, Jack Henry serves banks and credit unions within what we call the community and regional banking space to compete against the Wells Fargo, the Chase, all of those folks in the ecosystem.
So if you could, let me introduce all of y'all to a game I like to play. It's called Hey Julie. It's a game I play quite frequently because, as we mentioned, I have a technical background and not as strong of a banking background. I've been in it for about 7 years, and of that, multiple of that was looking at how to build better digital experiences, not into the base of banking. And so I play a game called Hey Julie, where I ask Julie for insights that I absolutely have no idea, and that we're already halfway down a technical solution, and I want to make sure that we're not completely crazy for what we're about to build. Because, you know, they've been doing this for longer than we have. So we asked the question, hey, Julie. So now that you're all in on the game, we're going to play it a lot today. So hey, Julie, what exactly problem are we trying to solve by building a platform like this?
Time. We're trying to solve time. So banks operate today in a very time-constricted environment, right? So everything that happens today in a bank is all revolves around when the customer walks in, when they present them with a proof set, when that proof set runs through POD, when they pull in their ACH files, when they stop. And they have to stop their day to do what? They have to accrue interest, they have to do a service charge. As much as real time sounds awesome, like at some point a bank has to stop and figure out what balance we're talking about. Can we service charge you? Did you fall below your $1,000 this month? Well, we don't know unless we stop. So time is one of the biggest problems that we have to overcome with a bank today. And getting their mind across that line, which I see a couple of our banker friends in the audience today, they're like nodding along. Time is the biggest problem that we're trying to solve, to get them to move faster, but still give them the ability to have an accurate balance something that they can be confident that when a customer walks into the branch or the ATM or they're swiping their card, that it's all the same thing across all systems.
So what's this?
This is how I talk to our customers today. Now, this looks pretty simple, right? So when we're talking to our clients and we're trying to tell them this is what we're building, we want to break it down really simply. So here's your bank, here's your credit union. These are all the things that you need to do today to operate your bank, right? You have exception items. You have something that doesn't post. You're overdrawn. You have to actually work that item. That takes a human to sit and decide what to do with that item. You have transactions, accounts, cards. Who are your customers, right? Who are you? Who is Michael? What's the entity that belongs to Michael? Who's your family? All those things. Can you make a deposit? Can you make a wire? This is how I talk about it to our customers because this is very simple for them to understand because these are the things that they know and understand. Now, that's what I give to explain to them, but Chris, hey Chris, what does it really look like?
So this is our nice view that we like to talk about, and then it looks like this.
And this is real, by the way.
So if y'all haven't talked about observability and talked to the great folks that are the vendors out there in observability, it's great tooling, and we leverage it. And so this is an example of one of the schemas of how we present and create a front experience for a core today, meaningfully being able to present that information. And platforms seem all nice and have these nice defined components, but they don't work that way in practice. In reality, we have to deal with how do these things talk to each other? How do we deal with inconsistencies? How do we layer them in sort of building those? And most importantly, who's the actual source of truth? Because the source of truth is what's important when it comes to finance across the board. Somebody is in charge of each step of the way, and if you let go of that, then you open yourself to risk, which means that you have to be aware of who owns what pieces. So a long, long time ago, the platform ended up starting looking like something like this. This was a tiny little build when we first got observability stacked into the platform components. And we had a couple of stacks running together, and then we built this, and it got a little bit bigger, and we were like, okay, it's starting to get crazy. Maybe we should pay attention to that weird thing that's growing off on the right-hand side there that looks really crazy looking, and I don't really know why it has arrows that go back and forth, but that's not good engineering. So let's get rid of those arrows. And so then we got back to something like this, which is able to present a coherent experience around things like how do we move things, operate together, talk back and forth through something as simple as like a wire system, which, to be clear, is a simple use case relative to the space, even though wires are massively risky as an element of moving money, right? So now we have to talk about why any of what we just talked about in terms of these graphs actually matters by talking about how we bring things into a next-gen canonical core system, something that is the source of truth of information for where the money is so that we can match the liabilities or equities effectively and get that for the call reporting and other needs that financial institutions have. And most importantly, open up things that we couldn't do when we were using the other cores that were available within Jack Henry today. And that's really important, is that if we don't have something that we can offer that doesn't change things, then we're stuck. And so leveraging our technology allows us to unblock new options. So, who thought when talking about financial institutions we were going to end up talking about CAP theorem? I know that when I got into this, this was my biggest surprise relative to the entire space, because we thought that we were just going to go out, build a system, build a ledger, going to be a no big deal. No. So underneath the hood, we have these independent modules. Hey, Julie, how many modules are there in like something like Silver Lake?
If you talk about a module in the terms that I like to think about it, of end of day and all of the different places that money comes in or out, there's probably over 150 just within one of our core systems, and we have 4 core systems. Within that 150, those parameters that break down can bring money in from probably another 400 to 500 different places, and by the way, those are on different balances calculated in disparate systems. Make sense? No, not at all, but that's how cores work. So they have all these disparate systems that at one point in the day come together and talk to each other, but they all represent different places where the customer is throughout the day and where they are. Literally, if you walk down there and you buy something right through that store and you swipe your card, depending on what that store does with that and how quickly it gets back to our data center and then processes within our core and what else is happening within that day, the balance could be different for Brian 4 different places if he calls his bank within that hour period.
So it would be a consistent system where it gives a reasonable answer within each system, and it's set into each one of these modules that work together in these components. So I have simplified it into 3 squares, which aren't squares, details. The important item to see here is that the idea is that deposits and loans are functioning all the time and able to make decisions within them throughout the day. However, there's this ledger thing that's actually responsible for the financial institution, and it doesn't actually know what's happening all the time. It has to figure that out as it goes. And so as we move through this, we end up having to stop and get back everything into sync, because the ledger needs to know what's happening in these systems, and they have to talk to each other, but they can't, because they have to be independent systems so that they can be canonical for themselves. This comes with a lot of advantages and has worked for a really long time, but foundationally, at some point, you have to stop a system like this in order to be able to get it back into a consistent fashion so that everything agrees for at least 1 second of the day, which is about how long it lasts, before it keeps going forward again and they start diverging and then back in sync. I think of it like a treadmill where you're constantly catching up. So, essentially, it has downtime, and hard systems is that it normally pushes concepts into domains, because you have all of these. You have your ACH system and your wire system and your card system, and deposits has to figure out how to make sense of all of these different things. So you shove all the logic into this place to make sure it doesn't go wrong in deposits, because you don't want to have the wrong information. But now you have all of this held in different modules, and you have the same logic replicated over and over and over again, because you have to keep those logically separated within those modules.
One thing that you might want to keep in mind, and you all probably know this, but I'm just going to say it just in case. It's forgotten sometimes that a bank's ledger not only keeps them in balance and keeps them in compliance, but it also can earn them money, right? Because their Fed account, that's what they have with the Federal Reserve. They're earning interest on that money from the Fed, or they owe money to the Fed, and they are constantly keeping their reserves in this delicate balance so that they know if they come in, at any point in time, they can say, this is what we have at the Federal Reserve right now, this is what we have credit for, this is what we're earning interest on. So if that gets out of balance, balancing a Fed account is one of the biggest pieces of a banker's job, because it's really important to make sure that those monies are accounted for in what's happening all day, every day, right? Because when I pull in my ACH file as a banker, I'm not just getting transactions for that day. That ACH file has contents for 2 days in advance, 4 days in advance. If a company's getting ready to go on vacation, it could be effective dated 10 days out. That bank isn't going to pay on that deposit that day. They're going to hold it in their warehouse. They're going to maybe hold it in their Fed account. They're going to earn interest on it because they're not going to pay out on it. But they have to make sure they know what it is so they keep their reserves in balance. So everything that Chris just walked through is super important to the banker, because they don't want any of that. They don't want you to muck with that stuff, right? They want to make sure they understand it, because the Fed hasn't modernized in a while. I don't know if y'all know that or not, but like ISO was like the biggest deal they've done in a really long time, and they didn't do so great at it. It took a lot of years to get done. So everything he's talking about with the ledgers, while it seems very simplistic, it's really, really important for the bank to understand what we're talking about, because if we start talking about real time to a bank, they're going to immediately start asking, how am I going to earn interest on my Fed funds? And Chris is going to say, I don't know.
I think we'll figure that out. So, the next item on this is a consistent and available system. Y'all have been thinking a lot about this, where you kind of build a giant system. And then in the giant system, right, you need to end up bringing in more and more items to be able to create a rule set that understands the entire domain. So you can think about this as a monorepo, or if you think about it like a massive distributed system that may consistently update itself by, creating a chain of sorts. But for either one, you need to create a universal system that essentially allows you to build systems up, right? And then you may have ingress in these systems, but it requires that you have the logic of all of your vendors, of all of your risk relationships, of all of your components within that one system, which is massively limiting in terms of your engineering scope, in terms of how you're building things, and in course of technical availability of upstreams being involved in the process of that singular store. So, it's awesome in a lot of ways, right? Anybody who doesn't see the value of a monorepo-oriented design isn't seeing that there are big advantages to this space. However, it also comes at a massive slowdown at scale. So, instead, we ended up in a little bit of a different space, where we went with available and partition tolerance as our model. So, the main reasons what we found around this was that we needed to step back and ask ourselves about consistency. So, hey, Julie?
Oh boy. Yeah.
Is there any weird things about consistency in a financial institution today?
A little bit. There's a few things that are a little bit weird, yeah. Do you want one just as an
Absolutely.
example? Okay. All right. So one of the examples that I love to give is, and this is for our systems, and I think a lot of banking systems, it's a parameter, and banks can choose it. So that means of 1,200 different banks, 1,200 of them have them set a different way. But just for an example, if you get paid on the 15th, and the 15th falls on a Sunday, and you also have your house payment taken out on the 15th, so do you want your paycheck to post first, or do you want your house payment to post first if Sunday is not a processing day? Guessing most of us want our paycheck to post first, right? So we want that to happen on Friday, but we don't want the house payment to come out on Monday, right? So that's one example of something that an FI could choose to do a little bit differently. Some banks, believe it or not, will say, nope, go ahead and post that debit first, because they want your overdraft fee. That seems kind of unethical, doesn't it? But that happens. Then what if you have a holiday worked in there? What happens to that then? So all of those different kinds of logic that are within traditional core systems today are all parameterized. Believe it or not, some banks actually still post in check number order. Let that sink in for a minute. So as the checks come in, doesn't matter what order they come in, and they're going to save them all to the end of the day, and then they're going to post them in actual numerical order based on the check number. It's wild. I can't believe anybody still does that, but I checked pretty recently, and it's still a thing that happens today. Do you want your ACH to post before that? Yes, you probably do. But again, each bank can choose to do this different. Each credit union can choose to do this different based on what they've disclosed to their customers of how they're going to make their funds available.
So, consistency is already a very gray scale. So really what we care about is that you have the right balance in your account, because that's what matters for most of your decisioning process relative to that space. So now, rather than trying to aim for global consistency as a space, we can aim instead of the ability to modernize at scale. Utilizing PubSub, utilizing Spanner, we can actually make these independent components that scale and then unify together by moving sources of truth to the relevant parties. So in software, we have a tendency to want to put everything in a database, right? We love databases. However, the problem with databases is that they end up all looking like the thing that you want as your destination, not your transit. And your transit is often what we're actually working at in finance, the things that are moving, the things that are going. So let's go back to like the 1970s for 2 seconds, because in fact, not the 1970s. I'm going to go back to where we started this conversation, which was the pirate era. So we sat down and we went, how, if I was running a pirate ship, would I do the accounting? Because I'm going to take a ship, I'm going to go overseas, and I'm going to still have to balance my books to the guy who actually is going to be back there that has the general ledger for my ship that's functioning. How am I going to function in a world where I don't have any knowledge of what's happening within the main system? So accountants have actually solved this problem, surprisingly, almost like they had money for a really long time in this world. So instead, we decided to go take a look back, which is in journaling. So is everybody familiar, at least with the basics of journaling?
Yep.
Fantastic. So the idea behind journaling is that we're double entry debits and credits. It's fast and it's authoritative. Julie?
No boy. Yeah.
What books did y'all have when you started out in this industry?
What books?
Like did you have like a book for these journals at one point that you like moved into your T accounts?
Yeah, we did. Yeah, lots of books.
So what happened to those books?
Well, they got digitalized.
Uh-huh.
Yeah. But then we still took what was in the books and just put them onto a computer. It didn't happen automatically by any means. We still were looking at the physical items and making sure they balanced with what we put into the fancy computer.
So realistically, we had the books, we had the destination, which is the final accounting system, and then we digitalized that. And so then we built a whole bunch of systems that then built the processes of building those into the final destinations. And we lost the intermediates that actually mapped those realities. Like, money moved in the journals. Systems operated from those journals that people made decisions on, and now we can have computers make decisions on. So, essentially, the idea is that journals hold the value that's moving. They say that you have double entry. They hold the system that operates on these. However, we need ledgers that hold those values. However, who thinks that they should know about every subsystem of the core with the 150 modules in the general ledger for every transaction? That sounds like a great time, right? No? Then what we're going to need to do is build out a better system that builds subledger accounting that actually knows the information relevant to the domain in question that we're executing. That moves the responsibility so that general ledger is responsible for the overall balancing of the financial institution, for managing the overall economic state between modules, and for the subledgers communication between those. However, the subledgers themselves need to be able to know what's happening within those spaces and what they mean. So what's the balance of my deposit still needs to be there within the deposits domain, but they also know what the product or the branch or these other information that the general ledger shouldn't need to know in order to do its balancing. So looking back at this, you see that we're realizing pub sub events as our journals and our T accounts within spanner databases. What this means is that we get the availability of being able to get up-to-date information in real time, and that we can write records immediately, because we're making the rails responsible for the journals that they create, with the information flowing out of them from the deposits and subset systems. This means that essentially we are creating a system that records what's happening, records out the back door by eventing what has happened in the T accounting space, and then we can know within the journals when those have moved upstream. And utilizing eventing, that can happen in milliseconds, meaning that essentially we can get transactions fully through, posted, and back in milliseconds. So this is again, you're going to see a pattern of me liking to draw simple diagrams because I like simple diagrams. They make the world nicer than that giant cloud mess. Essentially, when we take all of these systems and we drop them out, we now can allow ledger and deposits to be fully decoupled from all of the rails. They can just be consumers that are moving it upstream, and then all of these systems can know everything about them, which have massively complex systems around them, so that we can say, what are the systems in ACH? What are the systems in wires? So the importance is the separation of roles. And the separation of roles allows us to actually move up and say, each one of these groups knows what's responsible in each one. We can build those as transactions, see as we modify the balance in real time, as well as all of the request information and all of the data that was originally linked to that request in its raw form, so that we can build a full pattern all the way through with raw data from transaction post back to the original ingress, whether that's incoming transactions from the Fed or whether that's a customer request. It's all saved there with the transaction and able to flow through in real time in seconds, not seconds, milliseconds.
One of the biggest pieces of, I think, history that's left out of what we're trying to do and how we're thinking about this is all the cores that were built today, the big cores, FIS, Fiserv, Jack Henry, it doesn't matter, all of those were built before the internet, which you all know, right? That means before online banking. So what happened within the online banking era is we have this core that was this one thing, this monolithic system of record, and then we had to build this digital thing over here to talk to it. So every digital banking core today that's out there, it is all integrating into something that wasn't meant to be integrated into from the internet. We've made it happen through all of you, through a lot of folks that have been really smart and figured out a lot of creative ways, but it really wasn't, like, that's not what was native on an AS400. That wasn't what was native on a big system. So as we've thought about these things and decoupling them, one of the things that we want to make sure we do is we build a new platform, the new Go Forward, that is going to be cloud native. It's going to be off of this big box, this big black box that it has always existed. So we can't just take that and say we need to rebuild all of that to be modern, but everything that talked to this, what needs to talk to this now? So as Chris and I talk through all of these things, and we have some very spirited conversations, as you can imagine, is what are we trying to do here to solve for the customer? What are we trying to solve for the bank or the credit union so that as they have this new thing, this new core, how do we build it in a way that gives them everything that they need, the stability and all of the balances that we already talked about that are so critical for them to operate, but then how do we also make sure that all of you can build into it in a way that it gives them products from now, more products than they can possibly think of, because we don't want to build everything. We want you all to build things. And we need to build a system that you understand that is modern, not this big IBM system that wasn't ever meant for you to talk to, but something that was designed out of the gate for you to talk to.
So we kind of walked around this whole topic, because Julie started on this, and then we went and talked about how cool we were going to do all this stuff in real time. And that was really fun. And we were really enjoying ourselves, right? We were like, yeah, we're going fast. We're going to write those transactions. They're going to get there. We're going to have everything in real time. And then we forgot about all that fun stuff that was still happening in the background. So one of the things that we kind of posited in this space is that real-time Rails can't stop, right? It doesn't make sense for real-time Rails to stop. So if we've done all this stuff and given up the component of full consistency to get this, it never stops, right? We better get the consequence of it out of it, which is that it keeps going. So essentially, I ended up in a 1-hour car ride at one point where we ended up trying to figure out everything we could do to make end of day nothing but day plus one. And we were like, how can I get rid of everything else in the system except day plus one? And then we realized that the financial institutions would not like it because they wouldn't get to hold that money for that period at all. So what we decided instead was a system by which we thought about time slightly differently. So when we do accrual, sorry, I almost forgot my keyword here. Hey, Julie.
Yes, Chris.
What does end of day look like today?
This is my absolute favorite slide. I made Chris put that in minutes ago. So this is an actual diagram of what a Jack Henry end of day looks like today. And if you zoomed in on this, which we will not do, but I would be happy to zoom in to it and talk to you about all the different pieces. Because what you see here is the actual process that a bank has to go through, and all of the things that have built in through the years, because a lot of these things, if you could zoom in, would be a hold wait. It's holding this file and waiting for the next thing so that it can get those transactions and make sure it's posting against the right balance, right? So this is a great example of online banking at its finest, because the Jack Henry systems, for example, like every other one out there, online banking came later. It had to be built into the core. So when you see, the very first thing that happens at the end of the day is your proof, by the way. Excuse me, it's your safe deposit boxes. I don't know how I forgot those guys. Safe deposit boxes still get processed on a bank system today. Safe deposit boxes happen first, and then your proof. That's all of the physical items that come in through a bank. Then your ATM files get pulled in, then your ACH files get pulled in, then your CDs process, and then your accruals happen within that CD. What if in your online banking you said, I want my CD interest to pay back to my DDA account instead of cutting me a check? Well, how is the CD processing going to know that if it hasn't gotten to the DDA first? So you're going to see a hold wait all through there. And in the online banking system, if you make a transfer, how do I know that you have a transfer made? So one of the very first things that online banking system had to do was look through the whole stack and see what order all of this happens in and make sure they're looking at the right thing all the way through. So when I first started a long time ago and did core conversions, end of day was one of our, that's when we literally ripped out their existing core and put them on a new core. And the first time we ran end of day was like the funnest part of the whole thing, because you got to see things just flying everywhere, and what interface lines didn't we get filled in, and what's going to unpost over here, and what What's these ATM transactions that, oh, we pulled it in 3 times and we have triple the transactions because that happened a lot. Stuff like that. So this is what end of day looks like today, and this is what you all are up against when you're trying to plug in. Where are you going to put your thing? How's the bank going to know? Like, where's this money coming from? Is it the right money? Is it against the right account? What if I closed the account? What if I was on a joint account and I got divorced today and then my ex tried to come take all my money? Or, yeah, that happens. Like, literally, walk into the bank and take it all before somebody can find out about it. All this stuff has to be represented in how we think about this going forward. The edge cases are too many to count, I think, which is representative here of how this looks today. So when I showed this to Chris and said, Chris, how are we going to solve for these things? It's a work in progress, right?
So end of day +1, right? We're just going to increase the date.
Just increase the date, that's all.
That's all it is. So what we kind of just settled on was instead that these journals that we talked about before instead need to know what they're talking about, right? Because real-time Rails don't stop. But if you need to do things because you owe people from yesterday, where does that go if everything doesn't stop? Like, theoretically, you need a place for the thing. And we thought, and we thought, and we thought, and then we decided to just make them happen at the same time. Because foundationally, accrual, under no condition does accrual say you have to do it immediately relative to that item. What you are required to do is do it relative to that item and have it be responsible to the day that it is accrued, which means that it's represented in all subsequent days, which means that you have to do your accrual within the day. However, let's do it faster than the day, because I would like the balances to be represented quickly and effectively. So what you see here is essentially the idea that real-time Rails just end and cut over and move to the next day. Transfers, wires, ACH. However, you also see something like the ACH system there, which has much earlier times relative to its cutoff, because once you've sent the last file for the day, it is not going again. It doesn't matter that you want to end at midnight. It's already started tomorrow. You have accrued items relative to tomorrow, not today at that point, because you're not doing anything for those financial customers until that point. So we ended up being able to build the system. You cut over, we build our systems, and this was our first diagram. We actually built this through, and we're like, have to do it in this order, like this. It's going to go through, and then we're going to finally check to make sure everything's right, because of course we do. We need to make sure everything's right at the end of the day. However, it has to happen in tomorrow while today is happening, because that's how the time works, right? Cool, I'm glad we're all on the same day on nonlinear time, because it took me a long time. So this is what we ended up actually operating in terms of systems-wise. We were able to loop this through, operate there, down. This probably needs some updates. It's been a couple of months since I put this one in here. But this one is a pretty reasonable diagram that we're operating here. And this moves us to the system of accrual. Because when we end up operating this, we end up really fast running into the fact that these systems don't end up working. Because we are not effectively balancing because we're doing things on a cache basis. When we do things on a cache basis, the system is left open waiting for the other half of the transaction. So what we saw in these Rails is quite often they would be waiting for the other half, and when they're done, then we could close everything up. And that caused a real problem that the system couldn't close. Because if you're waiting for an item, you can't become tomorrow because today isn't finished yet.
It's a time machine. You can, but you shouldn't.
So we're stuck in today when we want to be in tomorrow. So in order to be in tomorrow, at the exact moment, we have to not be waiting on anything, which means that everything has to happen in real time. Everything. Which means that when you receive an ACH file, you need transactions. Yes, the effective date isn't there yet. Yes, the settlement date isn't there yet. Yes, no one has handed money to anybody else. It still needs to be there. And this allows the system to actually be able to operate in real time, whereas when you're in a cache-basis system, you're constantly waiting for settlement to be happening. Where is settlement? Where is the items? And so you're stuck. And you don't want to be stuck when you're dealing with processing like this. So our final closing component is really just talking about what the accruals mean. So Everybody in this room probably understands these systems better than I do, to be clear, because I understand the back part of this, and when I talk about this with bankers, they don't know the front part better than me. So I'm going to go way the heck past there. You swipe your card, it goes through, you get your acquirer, you get your network, you get your processor, you end up back at the core, and then you swap the liability. Then it goes all the way back again, then it finishes the post, and you go back again, and then you come back to the front again. When did I accrue that money? Which one of those actions took what bits of liability? Or was every single step in that chain a step of the liability system that had accrual that's not being represented based off of its settlement today? Whether that's being your restaurant, whether that's being your debit card, whether that's being a grocery store. Because everybody knows you walk into a grocery store, right? You put it in your cart and you walk out the front door. No? That's how you go to the grocery store, right? No, you walk to the cash register, right? And then you walk out the front door. What's the difference between those two states? Oh, right, imaginary accrual. The fact that you have, at that point, agreed that because you have a receipt in your hand, that you have the accrual in place. Except for all the people who don't get their receipts, and therefore it is actually imaginary between you and the grocery store as you've walked out the front door without your receipt, and you just put everything in your cart and left. So accrual is both real and tangible. It is both delayed and realistic, and it is actually the ephemeral nature of us connecting with each other and having agreements between people. And when we're representing those in computer systems, we actually need to know about these systems and how they're happening, because otherwise we're lacking the information to make good decisions, and essentially we're waiting on some event that'll happen in the future. And if you're waiting on an event to happen, it can't happen now. And so to get real time, we have to move the information forward until we can make decisions.
I see a lot of like, well, okay. So I think there might be some questions. I don't know. We will be glad to take any questions about what we went over. Yeah. Mm-hmm. Mm-hmm. Repeat the question, sorry. Yeah.
Okay, so if I'm trying to repeat the question, I missed the very end of it. When we were working on accrual, we needed to what?
Are you relying on true time windows with Spanner?
In order to do that, we are not relying on true time windows for Spanner. Spanner is our consistency store for a high availability active stance. However, in terms of the system that we're operating on, it's the system that makes the decision record that owns the system of record relative to what decision is being made for accrual. So you should have an action that ingresses into the system in some way, whether that's end user, external, card, fed. There are a lot of different ingresses to a system like this, and then you need to record that, and then that's the accrual activity that we then record, and then those are then the journal of record. Because let's say that Abby is operating with one person and puts that in a book, and Wade is operating with a different person and puts that in a different book. Realistically, it's going to depend on what time they write in the book. That's going to be how you move that upstream. It's not the actual system time as though it's a global constraint. It's the fact that people are making decisions in a historical context, and systems are making decisions at scale in this context. So somebody's time is being leveraged, and you're moving it within one system of financial time and one system of financial record, being whatever the currency system that you're leveraging for the accounting system.
Bitemporal?
What?
Bitemporal.
So bitemporal, yes.
Mm-hmm. Yeah. Good question. Yeah.
What is the most surprising thing now, looking back? Talk about surprises along the way. Looking back, what do you feel like, if only I knew?
So the question is, what is the most surprising thing along the way that if only I knew? So I would say that more than likely, the most surprising thing along every step of the way is the times I have a conversation with Julie. Because we have this really complicated idea where we're like, all right, now hear me out, all right? It's really a composite. It's going to be wild. It's going to go sideways. We're going to make these transactions do this thing, and we think that we haven't seen this before. And she goes, oh, that's a subroutine. It runs there like half an hour ago. And you're like, what? We didn't even know that that system existed underneath the space, but Julie did. And so often it's the small items that are understated that folks know that aren't ubiquitous in knowledge of how systems operate that are the most surprising, because a lot of these edge cases that we think to solve with technology have already been solved in banking.
Chris calls them banking edge cases. I call them banking. That's it. Like it's just how banking works. But to your question earlier too about like how the transactions, one of the things that I was thinking about when Chris was explaining it is, do you think that a bank is really going to want to pay your, let's just say, are they going to want to pay your monthly Netflix bill if your loan payment is late? Like, what are they going to choose to take first? The bank is going to choose to take what is theirs. They want to take all of theirs first. So if they've already cashed out for the day, people have came in and they've wrote checks, or they've taken money out of the ATM, or they've done whatever they wanted to do, the bank is out that money. It's literally gone. But if you have this recurring payment out here that's not to them and they don't have to pay it, they're going to make the decision to take theirs first. That's just common. So what we have to think about in all of these systems where he's writing all these different transactions and how we're storing those is to make sure we still give the bank the flexibility to choose what they're going to pay. Because it can't really be in the order that they come in, because that might not be the order that they want to pay them, as much as that could pain all of us, because we're just the consumer. We're just out spending the money, right? But the bank may not want to pay it in that order. So we have to make sure we're capturing it in a way and reflecting it in a way back to the customer and the bank where they know what order has been paid and why.
Note how these are all accrual activities again. Everything that we're talking about is something that is based off of some other action that has happened in the future, that is now happening, and now, assuming a fixed time system again within a date, realistically, the start of day, as opposed to the end of day, creates a flexibility space for how you operate within the accruals within a singular day. However, end of day doesn't offer the same flexibility relative to those items. Those are all relative to a single day, whereas start of day, which is a phrase I like a little bit, is the idea of all of these items that you've done that now need to flush, that now need to operate and come into the financial reality because the day has become the day that those things are due. And you see that a lot in ACH, you see that a lot in final settlements, you see that a lot in these secondary systems where you need to connect two subsystems to reconcile how systems are operating between ACH and cards and other things that all need to come back together so that you can make sure that all of your bases are covered.
One of the most interesting things in a bank, especially going all the way back to a core conversion, is one of the first questions we would ask about their old system is, do you accrue to or through? And they would kind of look at you like, what do you mean? It's like, when we get your files, when we get all of your balances from your old banking system, are you accrued to or through? Well, we're walking in on a Thursday night, and I just want to know if the files I'm getting have the interest for Thursday or not. That's all I'm asking. Or if when I get that for Thursday, if I'm also going to have Friday's interest there, because all systems do it differently. So when we're talking about all of these accrual methods, we have to think about how each bank wants to capture that. Are they going to accrue through the day? When I'm done processing on Friday, am I accrued all the way through Monday or just to Monday? And what does that look like? Because all of that has to be represented where a bank can see it and they can pay out on it. So your savings account pays the right interest. If your statement cuts on a Friday, do any of you know if you get Saturday and Sunday's interest? Probably not. It's probably not something you've ever thought about. But if you sit down and actually do the calculation, it's important to understand that those are the things that we are we are accounting for in everything that we're building, because those have to be reflected back to the customers and back to the banks.
It also helps that, as opposed to the other systems that shut down their financial systems on Saturday and Sunday, we're just going to keep running a financial system throughout the weekend, because FI doesn't cease to function just because the Fed is not functioning. That may have been true in the 1950s, not so much now, where these systems need to give meaningful inputs and should actually have what has happened today and operate through the lens of, this is a real-time transaction. What's the information I need to know today on Sunday? Not, I'll find out on Monday. Again, we're waiting on the future.
Yeah. Any other questions? I think we got like a minute left, so. Oh, wait.
Historically, risk-based deposits
Yeah. So the question is, what are we thinking about risk-based deposit systems like checks, ACH, et cetera? And it's one of my favorite topics because it unearths the fact that a lot of these things that we're talking about are secret secondary items that are relative to accounts in these systems. They're holding value that you're choosing to unearth via secondary account systems that we don't leverage and lift forward, right? So I often make the joke internally that ACH Warehouse is the only warehouse I know that doesn't have an inventory management system. Because when it comes to working on ACH, right, realistically the accrual event is the ingress, right? But how you choose to process at that point is then the risk-based processing. What you make available, you have your Reg CC constraints, which you have to do, and then you have anything above or below that, not above that you want to make available relative to that item and on what timeline you want to make that available, and your system can do any of that. Because realistically, at that point, that's the FI's choice of how they want to make those systems happen, but then that's coming out of their ledgers, right? Something has to fund that. And it's really important that we're starting to talk about the second side of the equation, which isn't just, well, we will effectively y'all all know the idea, you know, that we have effective balance and you're eventually going to be consistent. Well, what if that was the case for, you know, like your settlement window for the Fed, where you just eventually ended up in the right state? Instead, we would like to capture what your actual Fed balance is all the time, know these values, and then be able to pay out via the secondary accounts that we haven't been tracking through the process today. And so by that, we just allow ourselves to configure and choose what our risk payments are and be able to hold the entire accrual of a check of an ACH item and get those available, and then hold those for making sure that we get those money back out relative to those intermediates when we finally do our settlement.
One of the things that I'm pretty vocal with Chris about is I don't think today banks have a good way to see their risk. I don't think they even know that it's there in all of the different systems, because they are looking at the ACH people are looking here, and the wires folks are looking here, and then the proof of deposit people are working here. But what is at risk with Julie right now? Like, how much money across all these systems is in float or in some kind of an in-process account that nobody's really tracking? So everybody thinks real time is so risky, but it's more risky how it sets today in all these disparate systems, and all we want to do is bring it all forward so they can see it all in one spot. Because I think that's going to be the real value add of real time. Yeah, real-time payments is real-time fraud, but also, what about all this money that's sitting over here that you don't even know what's going on with until its effective date in 2 days? That might be a real big problem, right? Yes? That's one of the goals, is to show them, like, yes, all of their outstanding items that have yet to settle, yes, or do they want to choose to settle that sooner? Like, we would prefer that they choose to settle it within the bounds of, you know, the regulations and anything that they have control over. We were just having a conversation earlier about Reg CC and FIs that choose to give more than $100 on Reg CC. That's pretty common, right? Like, there's not anybody that really truly builds a Reg CC table anymore that makes you follow all those things. So we want to make sure that we're giving them the ability to see it all and then expose it to their customers if they see fit. Like, putting the control back in the hands of the FI is one of the biggest wins of everything that we're trying to build.
And again, availability. One of the big things is that, like, by connecting these systems all the way through, going back to that, we can allow this customization of being able to see where fraud is coming, how it looks in that, how they want to make decisions on that, how that wants to affect how the system operates in that, and be able to do all of those on the accrual actions in real time, which it means that they then affect the balances, affect the processes based off of that system. And so it allows the configurability of whatever we can essentially come up with to make things more available, and then creating the pathways to unearth these in ways that are more than just transactions. Because a transaction in an account is a T account, but a transaction that you see on a rail knows about the rail, which means that we can unearth a lot more information with a lot more understanding that's going into it than what we're doing today, where things start on a rail and then become a transaction, and then it's a terminal state where returning to that item that it started at is a very difficult and intensive process that is not visible to the financial institution. Yes.
Yes. Yeah.
So just to be clear, the question was, is there, not all transactions are the same. There's different risk associated with those and different items. Yes, absolutely.
I think we have taken our time. You guys are awesome. Thanks for staying awake for us.